this video we're going to look closely at parallel and perpendicular lines, mostly perpendicular lines. But first let's talk about parallel. We know what parallel lines are intuitively. They're railway tracks and telegraph wires, and they're lines which remain the same distance apart to their entire length. They will never ever cross each other, and they'll never ever get further apart from each other. Intuitively, if the lines are parallel, then their slopes must be equal. Dealing with perpendicular lines is a little bit more problematic and needs some time to explain. Perpendicular simply means that the lines are at right angles to each other. And suppose we have this line here and the point in the centre at 2, 2, and imagine rotating this line 90 degrees to be perpendicular to the current line. So, this is the original line, and the point that we pivoted around was here, which was the point 2, 2, and we pivoted around 90 degrees. In order to work out the slope of the blue line, let's try to find another point where it intersects the coordinate grid precisely, and we can see it's this one here. And then, very clearly, the slope is equal to the increase in y divided by the increase in x. And we can see from these two that we have 2 across and 1 up. So the increase in y is 1 and the increase in x is 2. So the slope of the blue line is 1/2. What about the slope of the red line? Well, again, the pivot point 2, 2, and another point there where it intersects the grid is down here at 3, 0. And we can see that we've gone down 2 and come across 1. This 2 has become the vertical drop, and the original 1 has now become the horizontal move. So the red line has an increase in y of -2, it's going down, and an increase in x of 1. So the slope of the red line is -2. So the original line had a slope of 1/2, 1/2, and the perpendicular to it has a slope of -2 or -2/1. In general, we can investigate how the two are related as follows. Consider the blue line first. Let's suppose we have the pivot point and another point over here, say, and we imagine a triangle in the x and the y linking them up. And suppose that the vertical increase was A and the horizontal increase was B. So the slope of the blue line is the increase in y divided by the increase in x, which is of course A/B. Now imagine that we rotate the blue line round to get the red line, and not only do we rotate the blue line, but we also rotate this grid of the triangle. So the triangle would now go there and across here. So the B, the longer length B on the blue line, has now become the vertical increase on the red line, and the shorter length A is now here. So how do we get the slope of the red line? Well, we can see straight away that it's going downhill, so the slope is bound to be negative. And from this point to this point, it has gone across A and down B. So the slope is the increase in y, which is -b, it's gone down b, over the increase in x, which was A. So one line has a slope of A/B, and the other line has a slope of -b/A. This is called the negative reciprocal, and this is the condition that two lines are perpendicular. So again, if one slope is a over b, then the other slope perpendicular to it will be minus b over a. Let's have a look at some examples. The first example, the slope is 3 or 3 over 1. Therefore the perpendicular slope is the negative reciprocal. So we change the sign and write it upside down. Instead of being 3 over 1, it is minus 1 over 3. Similarly, if the slope is minus 2, then that is minus 2 over 1. So we flip it upside down and change the sign. So instead of being minus 2 over 1, it's plus 1 over 2. If the slope is 3/4, then its perpendicular slope is minus 4/3. Similarly, minus 7/10 becomes 10/7, and 5/3 becomes minus 3/5. If the number is expressed as a decimal, we first have to convert it to a top-heavy fraction if necessary, or as a single fraction. So 2.5 is 2.5, which is 5 over 2. Therefore the slope perpendicular to that will be minus 2 over 5. And lastly, minus 1.6 is the same as minus 16/10, which is the same as minus 8/5. So the slope perpendicular to it will be plus 5/8. Okay, so we're going to look at a couple of typical examples of how to incorporate this knowledge about perpendicular slopes. And the most important equation to remember is the equation of a line given a known point and a known slope. Y minus y1 equals mx minus x1. So, find the equation of a straight line perpendicular to the line y equals 7 minus 3x passing through the point 6, 4. Well, 7 minus 3x clearly means it has a y-intercept of 7 and a slope of negative 3. So it's coming down quite quickly. So it probably looks something like this. And we want to find the perpendicular to that passing through the point 6, 4. 6, 4 is around here. So what I'm really trying to find is the equation of this dotted line. And we can see just from the sketch that it has a positive slope. So let's look at the original line, 7 minus 3x. As we know, the original slope is minus 3. So a slope perpendicular to this will be the negative reciprocal, not minus 3 over 1, but 1 over 3. Now that we know the point and the slope, we can put it into the equation. Y minus the y coordinate 4 is equal to 1/3 x minus the x coordinate 6. So expand that, y minus 4 equals 1/3 x, and 1/3 of 6 is 2, and 1/3 x minus 2, and then bring the minus 4 over, so y equals 1/3 x minus 2 plus the 4, or y equals 1/3 x plus 2. And again, you can tell from the sketch that pretty much looks right. Positive slope, quite low, and a positive intercept still. And finally, this second example, find the equation of the line passing through 8 minus 3. So 8 minus 3 is somewhere over here, and it needs to be perpendicular to the line passing through minus 3, minus 4, and 6, 8. So we've got a line which is pretty steep, and we need to find the equation of the line perpendicular to that passing through this known point. So it'll look something like that. The diagram is a bit rough. We can see that the intercept is going to be pretty close to the origin, but because of the diagram I don't actually know whether it will be positive or negative. but again we do know straight away that the slope of the line we want will be negative. So first of all we need to figure out the slope of the original line L1. It had -3, -4 and 6, 8. -3, -4 and 6, 8. So the slope is difference in the y coordinates, y2 minus y1, over the difference in the x coordinates, x2 minus x1. We have 8 and -4 for the y's, so that's 8 subtract -4, which is of course 8 plus 4, which is 12. And for the x's we have 6 subtract -3. 6 subtract -3 is the same as 6 plus 3, which is 9. So the slope is 12/9, which is 4/3. So the slope of our line, perpendicular to that, the perpendicular slope is the negative reciprocal of 4/3, which is -3/4. So we know the slope and we know the point 8, -3. So y minus y1 equals m x minus x1 gives us y subtract -3 is -3/4 x subtract 8. So tidy this up a bit. Y plus 3 is -3/4 x, and then be careful here, -3/4 multiplied by -8 is positive. 3 times 8 is 24 over 4, 12 is 6, so that is plus 6. So y plus 3 equals -3/4 x plus 6, and then move the 3 over and subtract, so we get y equals -3/4 x plus 3. As I originally surmised, the slope is negative and the y-intercept looks positive, but we weren't quite sure, but certainly it was going to be a smallish number, so this is the correct answer. So look back over these two examples, make sure you understand them. These are the basic form of questions, and they're pretty much all like this.